What if the Earth stopped spinning right now? Imagine that for a moment. One side baking in endless daylight, the other frozen in eternal night. It sounds like science fiction, but it's a powerful thought experiment to explore how fragile and dynamic our planet truly is. Today we'll walk through what would happen if Earth ceased to rotate and ended up always showing the same face to the sun, like a tidally locked moon. First, let's picture the setup. Earth currently spins once every 24 hours, giving us day and night, seasons, winds, currents. If rotation stopped, the sun would hang motionless in one spot in the sky. One hemisphere would live under constant daylight, the other in permanent darkness. But this isn't a clean, gentle shift. The consequences would cascade in stages, from immediate chaos to long-term rebalancing. To begin, imagine the moment the spin slows to zero. The ground, the atmosphere, the oceans, everything moving with Earth's rotation, would keep going. Massive windstorms would whip across the globe. Oceans would surge. Giant tsunamis would race inland. Entire mountain ranges might fracture. But what if the slowing were gradual, over centuries? The damage would be less apocalyptic but still extreme. Over time, the bulge at Earth's equator, caused by centrifugal force, would collapse. Water currently held around the equator would migrate toward the poles. Polar regions would flood. Lowlands near the equator might emerge as new landmasses. Coastlines would be utterly redrawn. Our weather patterns, driven by rotation and Coriolis forces, would break down. Winds would collapse into direct flows from hot to cold zones. The magnetic field might weaken because Earth's core dynamics depend partly on rotation. Over time, cosmic radiation and solar particles could penetrate more deeply. As the stationary sun beats down on one side, that daylight hemisphere would heat dramatically. The night side would freeze, possibly locking up gases and moisture. But Earth isn't just rock. It has an atmosphere, winds, oceans that could carry heat across that boundary. Some circulation would try to equalize temperature. Climate models of tidally locked planets show that winds from the hot side to cold side might moderate extremes, but still a huge contrast remains. Deep in the darkness, gases like carbon dioxide and even nitrogen might condense or freeze out, thinning the atmosphere on that side. Water vapor evaporated on the hot side could blow into the twilight zone and precipitate there, possibly forming a ring of life in that narrow twilight band. The dark side might become an icy wasteland, hundreds of kilometers thick in ice, possibly with a subglacial ocean beneath if pressure is high. But here's the twist. Earth already is slowly slowing down, thanks to the moon's tidal friction. Someday, far into the distant future, some have speculated Earth might become tidally locked to the moon, or even to the sun. Yet before that could happen, the sun will evolve. The seas will boil, continents will drift, so a perfectly locked Earth might never exist in reality. The takeaway: our spinning world is a delicate balance forged by motion. Without it, extremes dominate: fire and frost, chaos and silence. Thinking about a world forever split between blazing day and frozen night reminds us how precious our dynamic climate and balance truly are. So the next time you watch the sun set and rise, remember, Earth's spin is not just motion, it's life.